A very good morning students. Today I am here by taking a new topic concerning with your NEET examination, state board examination and CBSE board examination, that is what the action potential. In our previous video we have studied about resting membrane potential. Here we are going to see a different concept related to the nerve impulse, that is what the action potential. So what actually the action potential is, as any stimulus, likewise any pin touches to a particular part and that message reaches to your neuron, then right part, a impulse is generated and that nerve impulse reaches to the whole neuron is known as what the action potential. So we can define it in another way: conduction of nerve impulse on arrival of stimulus. As any stimulus arises to the neuron, the conduction of impulse occurs known as what the action potential. So here we will try to see what actually is happening and how this whole phenomena is occurring. Okay, so here I have taken a cell, and by seeing it you all are getting that it is nothing besides the neuron or a nerve cell, and it is the dendrite part and it is the axon part of a neuron. You are seeing one thing very clearly over here, that is what this neuronal cell is positive outside and negative inside. Okay, outside the cell is having a positive charge and inside the cell is having a negative charge, and in this state we say what a RMP or resting membrane potential. What we say it, resting membrane potential, and its value is what, minus 70 millivolt. So we can say when our cell is in its resting state, it is having a value which is in negative, known as what is that, minus 70 millivolt. We say what a resting membrane potential. Now let's see what actually is happening. As any stimulus arises, okay, to a neuronal cell, its polarity just reverses. Okay, its polarity just reverses and it's become negative from outside and positive from inside. If that particular situation is arising, we say it what an action potential. Now your membrane has reached into a territory, positive territory, that is what a up to plus 40 millivolt, and we say it what a action potential. We will try to see how this whole process is occurring. Meaning is that the normal cell, which is having an unstimulated cell, which is having a resting membrane potential of minus 70 millivolt, and suddenly as an stimulus arises, it reaches to a positive territory, that is what a plus 40 millivolt. How it is happening? Why there is the reversal of this polarity, positive and negative from inside changes to the negative from outside and positive to inside. There must be some mechanism behind it. We will try to understand it here now. Okay. Before we understand about the whole concept of resting membrane potential, let's discuss about certain channels or gates which are present on the axonal membrane. If I say it's the nerve cell's axon part, okay, it's a bilayered structure, one part and another part. It's the outside of the membrane, it's the inside of the membrane. Outside the membrane is having always and always positive charge, inside the membrane is having always and always negative charge. Why it is happening, we have discussed it into our previous video, in that we have seen the concentration of sodium ion is more outside, and in the intracellular fluid the concentration of potassium ion is much more high. That's why there is the difference in these ions. And what actually you are seeing, just to govern this electrochemical or electrical difference, there is the presence of certain channels. Let's see what actually these are. First of all, in our membrane is presence of a potassium channel which takes potassium outside of the cells. Again, we are having a sodium channel which takes sodium ion from outside to inside. Okay, why these both channels are working? Because we know potassium is more in concentration inside, so it moves from inside to outside according to the concentration gradient or down the concentration gradient, and sodium is present higher outside than inside, so again sodium moves from its higher concentration towards low concentration down the concentration gradient. So these are the potassium channel, these are the sodium channel. Besides it, we have studied about another channel, that was the sodium potassium pump or sodium potassium ATPase. It is an electrogenic pump which works on the presence of or the expense of energy, that is what ATP. If you are investing an ATP over here, what actually is happening? 3 sodium ions are pushed outside and 2 potassium ions are taken inside. So these are the 3 channels or pumps which we have seen over here. Always remember, first is what the potassium pump, which is taking potassium inside of the cell towards the outside according to the concentration gradient. Next is what the sodium ion, which is taking sodium ion from outside to inside according to the concentration gradient. And third is what the sodium potassium pump, which is taking 3 sodium outside and 2 potassium inside. So it's all about the channels and pumps which are present into the neuronal membrane. Now let's see what actually is happening when any stimulus is striking on the neuronal membrane and the polarity of the membrane just reverses. Okay, so here I have tried to summarize this all by the help of these diagrams. So what actually is happening? First of all, we are seeing a stage known as what? The resting stage. Okay, resting stage. What actually is happening in case of resting stage in the neuronal membrane? Okay, if I say it's a membrane, okay, it's a neuronal membrane or plasma membrane which is having the lipid bilayer. In this, I have shown one is what the sodium pump, another is what the potassium channel. Sodium channel and potassium channel. Okay, in the resting stage, a sodium activation gate is inactivated. It is not allowing any entry of sodium ion inside. Okay, it is not allowing any entry of sodium inside. You know one thing very well, we have seen it in our previous video, what sodium ions are present in higher concentration towards the outside. So now sodium cannot enter into the cell. Why? Because of the sodium gate is inactivated. If I talk about the potassium channel, these are also closed. These are also closed because potassium concentration is high inside than outside. Okay, so in the resting state, what we are saying, sodium gate and potassium gates are closed. Okay, and in that state, no movement of ions is occurring, and the membrane is going to be what? In a calm state, in the resting state, in the unstimulated state, where it is going to be what? Negative inside and positive outside, and maintaining a resting membrane potential, that is what? A minus 70 millivolt. Our membrane is what? In a negative territory. Okay, in next stage, what is happening? A stimulus strikes. Okay, a stimulus is striking over here and certain changes occurring in which the polarity has changed. Outside the membrane become negative and inside become membrane positive. So how it is happening? This stage is known as what? The depolarization. That was what? The resting state. Next is what? The depolarization. In this, what actually is happening, as any stimulus is striking on the cell, these sodium channels open up. This sodium channel is going to open up, so most of the sodium which is present outside enters into the cell. As it is entering into the cell, what actually is happening? More positive charge enters into the cell, so membrane become positive from the inside. Okay, and the potassium channels are closed, so no potassium is moving outside, only the sodium is entering into it. As sodium is entering into it, most of the negative charge is minimized and all the membrane become the positive from the inside. It is known as what? The depolarization, in which sodium channels open. Okay, next we talk about the repolarization. Okay, what actually is happening in case of the repolarization? We are again seeing membrane is reaching back to its territory. Likewise, when it was an action potential, बाहर से नेगेटिव हो गए थे, अंदर से पॉजिटिव हो गए. अब वापस से जब रीपोलराइजेशन होगा तो यहाँ पर क्या स्टेट आएगी? बाहर से पॉजिटिव और अंदर से negative हो जाएंगे. So in that case, what actually is happening? Potassium is moving outside by the help of potassium channels. Sodium is not entering and potassium is moving outside. Okay. So what actually is happening? Again, positive charge is reaching over here. If positive charge is reaching outside more, what actually is happening? The membrane is going to be positive from outside. Okay. So this stage is known as what? The repolarization, in which sodium channel closes and potassium channels open up. Okay. Last and foremost stage is what? The undershoot. Okay, what is that? Undershoot. In this stage, what actually is happening? Sodium channels are closed, so no sodium is entering into the cell, and potassium channels open up. As the potassium channels are going to open up, whatsoever the potassium is present inside, it's moving outside. So more positive charge reaches towards the outside, and more negative membrane is become negative from inside. Okay, so these are the 4 stages which are very important as far as the action potential appearing. और यही सारी stages की हम study करते हैं. पहला stage होता है हमारा resting stage, which is what a -70 millivolt. Next is what the depolarization. Okay, in which our membrane reaches to the 0 millivolt, then to the positive territory, that is what the 40 millivolt. Third is what the repolarization, membrane again reaches to the negative territory, and finally undershoot और ज्यादा negative हो जाते हैं, and after it reaches to a minimum stage, that is what a resting state. We have depicted this thing in the form of a graph which is present in various books as well. What you are seeing, we are placing membrane potential on one scale and time on the another scale. In that, first of all, our membrane is having -70 millivolt. Why our membrane is having -70 millivolt? Because of the presence of resting membrane potential, and after a depolarization where action potential is reached, repolarization, and finally to reaches to a particular state. So it's all about the action potential. Thank you all.